Okay, this is the definition of fluorescence in Britannica dictionary. Fluorescence in one statement is the emission of electromagnetic radiation by UV radiation caused by excitation of atoms in the material, which then re-emit almost immediately, okay, within about 10 to the power of -8 seconds. Okay, so imagine UV visible spectroscopy. Okay, from the ground state, when the molecule at ground state, relaxed state, and then it's been bombarded with UV or visible radiation, it will get excited into single or the first electronic singlet state. However, in fluorescence, after the molecule absorbs light, okay, it takes time for it to re-emit another light in terms of radiation, another radiation. So the instrument will take up this fluorescing radiation and measure how much is the fluorescent. Okay. Fluorescence occur when it returns to the ground singlet state by emission of photon. So this is the fluorescent. When I say ground singlet state, okay, it should be singlet state, because when it involves triplet state, then it's not fluorescent, it's actually phosphorescent. We'll go to phosphorescent. In order to understand the fluorescence inside Jablonski diagram, we have to recap, okay, defining some term that we learned in basic chemistry once upon a time. Okay, so the electron is usually in ground state, which is singlet state, whereby they are having different spinning direction. Okay, sini bawah. That's it. Okay, when it is starting to get excited, okay, to singlet state, okay, it will go to higher energy level, but still in different spinning arrow. While if let's say you have excited state but in triplet state, the spinning is lost, whereby the net of spin is 0. Okay, so this is where the phosphorescence happen. This is where the fluorescence happen. Okay, let us go into Jablonski diagram. I hope you can relate with what you learn with spectroscopy principle with Dr. J, I guess, with what we are going to learn in electrical chemistry in terms of like manipulating the spectroscopy principle for us to analyze sample. Okay, so just now at the ground state, we have like, okay, at the relaxed ground state on the singlet state, okay, ground singlet state, okay, after it's been bombarded with UV radiation, for example, it will go up here, okay, to the second singlet state, excited state. Okay, in any fluorescing compound, it contains extra features for it to fluoresce. Not all compound containing chromophore will fluoresce. Okay, we will learn about the requirement for it to fluoresce after we understand the fluorescent phenomena in Jablonski diagram. Okay, it will take, for example, if let's say the spinning, the singlet state will go over here. After some time, this whole thing will move towards longer wavelength. Sebab apa? Longer wavelength kan ni? Okay, longer wavelength. And then at lower energy level, this is lower energy level. And then it will go and emit a radiation, what we call as fluorescent. This is radiation that is emitted radiation. So you see that it is now moving from the second excited singlet state in towards the first excited singlet state. Okay, but still they are singlet state, means that the spinning is still different to each other. Okay, so it is emitting the radiation of fluorescence towards the lower energy level. Okay, lower energy level, some of it go towards ground state by in staggering manner. Okay, at this point you see that it absorbs at relatively shorter wavelength sini, while this one the wavelength is relatively longer than the first one. Okay, means that the energy over here is higher than what we have over here. Okay. Okay. So relate back with the energy and wavelength relationship. The longer the wavelength means that the energy is higher. That's why Jablonski draw this whole level of energy lower than the first absorption. What happened? Okay, if the singlet state convert to triplet state. Triplet state means that the electron spinning is now the same. Sini or this one. Okay. So that's what we call as delayed emission. It means that we still have another emission, radiation, what we call as phosphorescence. This phosphorescence happen even longer than fluorescent. In the first few slides, I said that it can be up to minute that can give you the glow in the dark toys. Okay, because it is delayed by certain chemical feature inside the phosphorescing compound, and ultimately it want to relax towards ground state. Okay, everything that is excited must come down and relax, and in the middle of the relaxation it will emit phosphorescence. Okay, and in the meantime we also have other radiationless non-radiative relaxation. So any chemical compound that is excited want to relax, be it radiation such as fluorescent or phosphorescent, or non-radiation relaxation. That's what we have as internal conversion, inter-system crossing, and also internal and external conversion over here. So it want to relax. So internal conversion, okay, I'll go back to this one here later. So in internal conversion, okay, so we have the transfer of the excess energy of the species in the lowest vibrational level of an excited electronic state to a lower electronic state. Means that it is converting the energy from the second singlet electronic state towards the first singlet electronic state. And then we have inter-system crossing, whereby the analyte move from higher electronic level from singlet to triplet. This is where we have the phosphorescence. Okay. Well, this one is between absorption and fluorescence. Okay. Why do you need to understand this? Because this kind of relaxation, be it radiation or non-radiation, will be affected by several conditions inside your sample or inside your instrument. Later we will learn about it. Okay, now I want to go back to the Jablonski diagram I explained just now. Okay, I want to show you how imminent the understanding the longer wavelength or shorter wavelength. So when it is excited, okay, the Jablonski over here, energy level, okay, from ground state, you see that this is wavelength number 1, this is wavelength number 3, this is towards longer wavelength, and then it excited means that the wavelength is around what, 480 over here, 480 nanometer. Okay, you see that it is absorbing nearing UV radiation. Okay, and then when it start to fluoresce, okay, okay, the energy level go down, and also the wavelength is like towards a longer wavelength. That's why the emission, the fluorescent is around 500 and 550 nanometer, because we have excitation wavelength and emission wavelength. Therefore, we can predict that, oh, my monochromator, my filter system must contain at least 2 parts. In UV visible spectroscopy, we have only one. Okay, we have slit, and then we have prism or diffraction grating, and then we have slit again. So it's direct. But this time, you have two. One is excitation and absorption, and then when one is emission spectrum. So we are going to have a perpendicular optical rearrangement. So we are going to cover that later. And also you see the color from blue towards purple. Okay, this is only can be seen in terms of imminent color in the fluorescent spectrometer only. Well, for phosphorescent, as I mentioned just now, when the electron in a singlet excited state is transformed to a triplet excited state. Ni you better buka buku balik and understand what is triplet excited state, everything. So in which the spin is no longer paired in the ground state. So when we have the delayed emission, therefore we have phosphorescent. Delayed emission at even longer wavelength. Okay. So I will show, no, I will not show. You can copy this, okay, or find like for luminescent in YouTube, and then you can see how the electronic transition as well as the animation of the singlet or triplet state. Okay, now please be part of this active learning, whereby you and your friend work in pair. I know it's not face to face, but you still can do an interview via video call, or you can record your own video asking about certain topic for the student. Okay, each student find info on each designated topic. Topic A, student A is electronic spin. Topic for student B is Jablonski diagram. Okay, so one do Jablonski diagram, one do electronic spin. Do like around 5 minutes video. Okay, change video between two of you. And then make sure that your friend understand what is the other topic that is not the same with you. Okay, and also you can also cover the part how electronic spin is related with fluorescent and phosphorescent, and how also to make sure your friend is understanding the Jablonski diagram. Okay, you may be asked to upload the video in e-learning. Later I will decide.